Hi mathematicians, in this video we're going to learn a few more derivative rules. Now these are rules that you should really memorize, and you can watch the video in AP Classroom that will justify a few of the rules. It looks like a lot, but we've already done the first four. What we are adding are the trig rules. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant is secant times tangent. Cosecant derivative is cosecant times cotangent. E to the x is e to the x, it stays the same. And the derivative of ln of x is 1 over x, or x to the negative 1. So let's use these rules to find the derivatives of these various functions. If w of t equals 3 secant t minus cosine t, find w prime of t. I'm going to look secant t, so that's this rule right here. The derivative of secant is secant tangent, and I'm going to put whatever's inside. So I know this part here, and when we have a coefficient in front, this coefficient is just going to stay there. So that's 3 secant t tangent t. And now this coefficient is going to stay there, minus 6. And the derivative of cosine, if we look, here's cosine, is negative sine. And I'm going to put in my t. And that's it. We could clean it up a little bit. And we should write our derivative notation. So we have w prime of t equals 3 secant t tangent t. Negative negative is positive, 6 sine t. Now you try the next one. If h of x equals 10 cotangent x plus sine x, then h prime of x equals, so let's see, h prime of x, I'm going to put my coefficient down. Derivative of cotangent is negative cosecant squared, and keep these inside the same. Since it's negative, I'm going to put my negative in the front of my 10. Cosecant squared x, and the derivative of sine is cosine, so plus cosine x. That's it. Let's try another example together. If p of a equals 3e to the a minus 5 ln of a plus 2 divided 3a minus cube root of a squared. So because I have these fractions and radicals, I have to rewrite this first. So p of a equals 3e to the a minus 5 ln of a. All of that stays the same. I'm going to bring out this fraction, 2 over 3. My exponent with the a is 1. And if I have something in the denominator and I want to bring it to the top, I change the sign of the exponent. So I'm going to have a to the negative 1. And then for this term, it's always going to be rewritten with the power over the root. So I'm going to put minus a. The power is 2, and the root is 3. Now that I've rewritten it, I can take my derivative. So p prime of a equals, put my coefficient in front. The derivative of e to the x is e to the x. So the derivative of e to the a is e to the a. Minus 5, bring that coefficient along for the ride. And then ln of x is x to the negative 1 or 1 over x. You can choose whichever one you want. And then the derivative of 2/3 a to the negative 1. I'm going to move my exponent to the front. So that will become negative 1 times 2 over 3, which is negative 2 over 3. A and subtract 1, right? I'm using my power rule here. Negative 1 minus 1 is negative 2. And I'm using my power rule again. Bring my exponent to be the coefficient. A, and I subtract 1. I have 2 over 3 minus 1. That's the same as 3 over 3. And 2 minus 3 is negative 1 over 3. You can rewrite that if you want. You don't have to. I'm going to leave it like that. Now you try this last example. So we're trying to find g prime of t. We're going to bring our constant in the front. Ln of t becomes t to the negative 1, stays the same, plus 3 e to the t. Derivative of tangent t is secant squared, so minus secant squared t. This is my derivative here. And I'm noticing, oops, I didn't rewrite this term, so let me do this on the side. If I rewrite this, my exponent is 2, so I'm going to bring that up. 1t to the negative 2, change the sign of the exponent. And that 1 just stays in front. So the derivative of this, negative 2 multiply 1 is negative 2. T, negative 2 minus 1 is negative 3. Here we have a constant, and the derivative of a constant is 0, so I don't need to write it. So all you need to do is know which rule you're applying and put it in for the derivative. So it's very important that you memorize all of these rules.